Hello class, my name is Miss Teacher. Today we are going to graph this rational function and answer all of these questions. Now do it.
Wait, we've never seen anything like this before. What is a rational function?
Well class, a rational function is the ratio between two polynomials.
But how do we approach this problem?
Well, student A, first you have to find the x and y intercepts.
Wait, I know what an x-intercept is. It's where the graph intersects the x-axis at 0. I can find this by setting the function equal to 0. And after doing my work, I basically get the numerator equal to 0. And this equals 0, which means the x-intercept is at 0, 0.
Now, does anyone know how to find the y-intercept?
I do. The y-intercept, that's where the function intercepts the y-axis. So all I have to do is substitute x for 0. And that equals 0. So the y-intercept must be at 0, 0.
Good job, student C. Now, I know asymptotes are new to you guys. An asymptote is a line that a function approaches but never actually crosses. VA stands for vertical asymptote, not Virginia. To find the vertical asymptote, you set the denominator equal to 0. Does anyone want to come up and demonstrate?
I do.
Good job, student A.
I know.
So, student A, why do you think we set the denominator equal to 0 to find the vertical asymptote?
Because if the denominator was 0, then the function would be undefined.
Good job, student A.
I know.
Next, we'll look at end-behavior asymptotes. Because end-behavior asymptotes are a little bit more complicated than vertical asymptotes, we're going to look at a little clip.
Yay.
End-behavior asymptotes consist of horizontal asymptotes and slant asymptotes. To find horizontal asymptotes, you check the degrees of the numerator and the denominator.
If the degree of the numerator equals the degree of the denominator, then the horizontal asymptote equation equals y equals the leading coefficient of the numerator over the leading coefficient of the denominator.
If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0, which is also the x-axis.
When the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. When the degree of the numerator is 1 more than the degree of the denominator, there is a slant asymptote. To find the slant asymptote, you divide the numerator by the denominator using long division. The quotient without the remainder is the equation of the slant asymptote. To find the crossing point between the slant asymptote and the graph, you set the remainder to 0 in order to find the x-coordinate of the crossing point. You then take that x-coordinate and you substitute it into the original function to find the y-coordinate of the crossing point, and then you have the ordered pair of the crossing point.
Now, after watching the clip, can anyone tell me what the end-behavior asymptote for this function is?
Ooh, I know. Because the degree of the numerator and denominator are the same, you have to make them a ratio, which means y equals 2, which is then our horizontal asymptote.
Good job, student B.
Oh, wait a second. Because crossing points only occur in slant asymptotes, and there is no slant asymptote in this graph, there is no crossing point.
Good job. Now we'll talk about symmetry. Symmetry could either be in respect to the y-axis or in respect to the origin. To have y-axis symmetry, if you plug in negative x for f of x, it should equal f of x. For origin symmetry, if you plug in negative x, it should equal negative f of x. Now, how do you think any of these symmetries can help you?
Because knowing the y-coordinate of a certain x value, you know that that y-coordinate will be the same for the corresponding negative x value.
And which symmetry is that for?
Y-axis symmetry.
Good job.
Thank you.
Now, can someone tell me the symmetry of this function?
Oh, let me try. If I replace the x's in this equation with negative x, then I still get f of x. Because if you raise a negative number to an even exponent, then I get a positive number, which means that this equation has y-axis symmetry. y-axis.
Wait, why isn't there x-axis symmetry?
Because if there were x-axis symmetry, then the equation wouldn't be a function because it wouldn't pass the vertical line test. Now we start to graph the equation. Okay. First, you plug in the x-intercepts. We already did that. Over here, it's 0, 0. The y-intercept is also the same, so we don't need to do that either. Then we plug in the asymptotes. Asymptotes are drawn with a dotted line. The vertical asymptotes are at x equals 2 and at x equals negative 2. There's a horizontal asymptote at y equals 2. To actually graph the equation, we start at the x-intercept. We know that this is a quadratic that points down because if it pointed up, then it would cross the horizontal asymptote. And we know that an asymptote is never crossed by a graph.
Are we done yet?
No, because there is more to the graph. We have to plug in points that are beyond the two vertical asymptotes. So for this one, you plug in 3 for x. So can somebody do that for me on the calculators?
F of 3 is 3.6. And because there's y-axis symmetry, f of negative 3 is also 3.6.
Good job, student C.
I know.
I can graph it for you.
Because I know that the graph approaches the two asymptotes, I can just follow the asymptotes. Ta-da!
Now this teacher challenges you to graph the rational function on your paper.
The equation is x cubed over x squared minus 9. To find the x-intercept, you set the numerator equal to 0. Therefore, the x-intercept is 0, 0. To find the y-intercept, you substitute x for 0. 0 cubed equals 0. 0 squared minus 9 equals negative 9. Therefore, the y-intercept equals 0, 0. To find the vertical asymptote, you set the denominator equal to 0. X squared minus 9 equals 0. X squared equals 9. X can either equal positive or negative 3. So the vertical asymptotes are x equals 3 or x equals negative 3.
Now, for end behavior asymptotes, because the numerator is exactly 1 degree greater than the denominator, then I would have to divide the numerator by the denominator. The zeros here act as placeholders. This would then equal x. If I subtract this out, then I would get plus 9x, which would then be the remainder, plus 9x, over the original denominator, which is x squared minus 9. Now for the cross point, I would set the remainder of the equation equal to 0. If I do this, then I get the answer x equals 0. And if I plug in 0 into the original equation, I also get 0, which means the cross point is at 0, 0.
As you can see, it's pretty obvious that there is no factor that's similar between the numerator and denominator, so there's no hole. None. Okay. Now, f of negative x is the same as this, and negative f of x is... And those are the same, so there must be origin symmetry. So, let's write down here. Origin. Yep, that's all. Alright, time to graph the equation. So first we have to graph the x-intercepts and y-intercepts. So the x-intercepts and y-intercepts are both at 0, 0. Okay, next we have to graph the vertical asymptotes, which are at x equals 3 and x equals negative 3. Okay. Next we have to graph the end behavior asymptote, which is at y equals x. Okay. And as we calculated, there is a crossing point at 0, 0, which is over here. and there's no hole, and the symmetry is origin, so that'll help us graph it. Now, time to plug in points.
As you can see, we drew a very accurate graph. Because there's origin symmetry, f of negative x equals negative f of x. That means f of 1 equals negative 1/8, and f of negative 4 equals negative 9.14, which are these 2 points. We continued following the asymptotes to continue graphing it, and because the crossing point is 0, 0, we drew that right here.
Okay, this is the answer to the problem. Remember, a hole is drawn with an open circle. I hope you were enlightened by this class. Thank you for joining Miss Teacher's classroom, and I hope you have a good day.
Yay!
Yay!